So galaxies obviously are collections of stars, right? Big collections of stars, and they have multiple types, right? So elliptical, spiral, and irregular are the three major types of galaxy, but that's not the only types. Elliptical are essentially just like
Are they tightly compact galaxies?
Yeah, I mean, all the galaxies are relatively compact, but what an elliptical galaxy is it's essentially just kind of this loosely bound. Yeah, it's kind of like an Oort cloud of stars. It's just a lot of stars all kind of
It's stuff.
in a somewhat orderly manner, right? They're not really organized in any specific way, except that they are more or less elliptical, right? Kind of semi-spherical. And here's an example of one, right? ESO 325-G004. Great name. And then the ones that we are most familiar with are spirals, right? Spiral galaxies are galaxies that obviously have a spiral shape to them. This is probably the most spectacular example of a spiral galaxy. This is called the pinwheel galaxy, or M101. Yeah.
Could gravity, like some like giant star kind of affect that?
Yeah. So at the center of all of these galaxies, you'll find a supermassive black hole. And a supermassive black hole is anything that has mass of over 1,000 suns. Most of the black holes in the center of these galaxies have millions of solar masses. And so really what's going on is that all of these stars are kind of orbiting around the center of the galaxy. They do it in a weird way, though, and we'll talk about that in a little bit. They do it in a way that doesn't make a lot of sense when you talk about Newtonian physics, Newtonian gravity. Something else is going on there, so we need to talk about that. And then irregular galaxies are just kind of haphazard, right? They don't really have a shape. They look more like a nebula. Okay? Here's what's interesting about spiral galaxies. So you may have heard of this guy before. His name, well, at least you've heard his name before. Edwin Hubble. He was a big fan of pipes. Look at this guy. He's constantly got a pipe. Pipe, 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 pipe. Oh, I guess those are the same pictures. Pipe. Anyway, Edwin Hubble, he was an astronomer. And back in his day, it was thought they were looking out using better and better telescopes, and they were looking and seeing these strange structures. And they thought that they were nebula, right? You've seen a nebula before, right? This is where stars are born. They look like this. Okay. That's a good image right there. They look like this. They're these gas and dust clouds out in space that form stars. The Orion Nebula. All right, so this nebula is in Orion. Well, they were seeing these structures that looked like nebula, but something was strange about them. They were more orderly. They started noticing the spiral ones first. And first they started calling them spiral nebula. Well, Hubble comes along and he says, there's something weird about these nebula. Because at his time, they thought that all of these nebula were within our galaxy, that the galaxy was the universe. Okay, the Milky Way galaxy was the universe. Like it was, and everything that we could see was all in this collection of millions of stars, they thought. Like that was the universe. And that these spiral objects were just nebula inside of our galaxy. Well, he came along and said, I think that they are separate galaxies. And this was a revolution because space, our understanding of space was pretty big, you know, something like 100,000 light years across. Seems unreasonably large compared to our little bodies and planet, right? Well, he said, no, these things are billions of light years away. And that really changed our understanding of how we looked out at the universe, how big it was. Well, come to find out that he was right. These are separate galaxies, and the Milky Way is just one of a lot of galaxies. Does anyone have a guess as to how many galaxies there are in the universe, approximately?
100 million.
That's a good guess, 100 million. That's a good guess. Any other guesses? Yeah. 100 trillion. Okay, you settle in between those two numbers. Repeat. Billions and billions. Yes, there are approximately 1 trillion galaxies in the observable universe that we know about. Well, that's a projection. Like we can't count all of them, right? So we're trying to do our best to do the math. There are approximately 1 trillion galaxies, and that's like the low estimate. So there are at least 1 trillion. Yeah.
What about the stars that disappeared over the
Cosmic horizon. Yeah, so we'll talk more about this when we get to cosmology and the cosmic horizon, the expansion of the universe and so forth. But yes, we know that there are things that are outside of the observable universe that are still in our universe. So observable meaning that we can see them. We know that there are things beyond that point. We have no idea how many there could possibly be.
Is it thin out as we reach the edges, or is it just as thick?
So again, this has to do with cosmology, but the distribution of matter throughout the universe seems to be pretty uniform. So the concentration of galaxies close to us is similar to the concentration of galaxies far away from us.
So then there could be infinite stars.
Oh, that's the question of is the universe infinite or finite? And that is a big matter of debate right now amongst astronomers. And so we'll get to that.
So wait, if it's infinite, could it technically not? I mean, like.
Yeah, that's the definition of infinite, right?
Well, I mean, like, there's supposed to end like starlight and whatnot, but if everything runs.
Oh, okay. So infinite in space, but maybe not in time. Again, this is all cosmology. We will get to cosmology, the cosmology of like, how is the universe going to end? How did it begin? How long is it going to be around? What is all this stuff here? Yeah.
So do we actually know that the universe is cooling, or is that just an assumption based on the Big Bang?
We know that the universe is cooling.
So even if, what is it, like, the plasma universe is correct, we still believe the universe is cooling?
Yeah, so we have to look at these different points in time, right? Space and time are connected, but we have to understand that like we're just in a little snippet of both, of space and time. So yeah, there's a lot of ideas though going around. And the evidence suggests one thing, but we could find more evidence that changes our mind. Yeah, Cameron? Yeah. All right. So 3 major types: elliptical, spiral, and irregular. There's also kind of sub categories. The most important one is a barred spiral galaxy, which looks like this. So you can see this bar. So spiral galaxies, sometimes they have like this weird straight line down the middle of them, and then they get spirally. So this is a barred spiral. But yeah, there's different kinds.
What causes the gaps between the atoms?
Just the way that the gravity clumps the stuff together when it's going around the galaxy. So kind of similar to how the planets form. The gravity in between different areas of the orbitals and how the stars interact with each other gravitationally can make gaps. Yeah. So, for instance, like if we look at this here, you get these like sinews, these strands of material. These are in relatively stable gravitational orientations to each other. Kind of the way that like Jupiter has asteroids that orbit in front of it and behind it in its orbit around the sun. This is a similar situation. They all interact with each other gravitationally. Yeah.
So how come the arms kind of curl back up and not just straight out?
So because these stars take longer to orbit around than these stars.
So would the arms kind of break apart with time? Or?
Yeah, so over time, galaxies become more and more elliptical. So over time, they become more and more elliptical unless they run into another galaxy, at which point they will become irregular. Okay, so possibly, in my opinion, no, Ryan. So that's not what I meant to spell. The bird galaxy. This is super interesting. This is called the bird galaxy. This is an irregular galaxy that is made of, what is going on? Oh, really? Couldn't load the image, huh? So this is 2 galaxies running into each other, almost edge on. Okay. This creates an irregular galaxy. These are not what I'm looking for. Wow. We got all these like galaxy firebird, phoenix. All right. Anyway. Yeah. So really cool.
I didn't know space had a white
Let's see here. Where is? Ooh, this one's cool. Yeah. 2 galaxies colliding into each other, and these stars are just getting thrown out. So each point of light in that image is a star. Well, each point of light here. These red ones are distant galaxies, but these stars are getting thrown out of their galaxies because of the gravitational interaction between the 2. So this creates an irregular galaxy. Okay? So, dark matter, in fact, this is really good stuff. This is kind of how I wanted to go into this. Dark matter makes galaxies more massive than we think that they should be. Does anyone know what dark matter is?
No.
Okay, well, all right. Could anyone give me a definition of what dark matter does? How about that?
It has mass, maybe. So
It has mass, maybe. Okay, so this is where we get to the limit of human knowledge. So if you were to go and if you go and look at these different galaxies, a lot of these galaxies appear to be more massive than they should be. Okay? So they have more gravitational pull than all their stars combined would add up to. And we're not talking about a little bit. We're talking about like 90-something% of everything that makes them up we cannot see. And we don't know why. In fact, I really don't think that they should call it dark matter. I think they should.
probably isn't matter to begin with,
What?
because it isn't matter to begin with, or
So, and that's the thing, we don't know if it's matter to begin with. I honestly think that we should call it Tina. Or like Gerald. I don't know, because we don't have any idea what it is. It could be matter. It might just be this weird quirk of gravity that we don't really understand. But we don't seem to see it on like smaller scales, okay? So there doesn't appear to be any dark matter in our solar system, making the gravity different. But for some reason, there appears to be dark matter in these galaxies, these galaxy groups. Okay? And this makes one of my very favorite things, and it is called gravitational lensing. We talked about this a little bit when we talked about black holes. But this is some wonky stuff. So this thing that goes around this other thing, this blue thing is actually behind the yellow thing. And it isn't a circle. It's a galaxy, like a spiral galaxy.
there's something blocking it.
It's not blocking it. Who's ready for one of Mr. Kroshaw's famous drawings? I know you all are. And you're so excited about it. Okay. Drawing time. All right. So we are here. All right. We are the observer. And let's say this is our telescope. All right. The telescope is here. And we're observing this elliptical galaxy. And this elliptical galaxy is blue. Okay, blue elliptical galaxy. There's all these stars here. And we think this is a pretty cool thing to look at. Yes, everything's to scale. And we notice that there is this strange circular pattern around this galaxy. And at first we think that it's like a part of the galaxy. But what it actually is a spiral galaxy. Oh boy, this is gonna be beautiful. I know you're all just super impressed. Oh shoot. Aha, there we go. This spiral galaxy that, okay. Well, as we look at it, let me turn the light off here. My drawing is a little bit. What is happening is the light, so we get light from here and it travels in a straight line. This light also travels in a straight line. It goes here. But the light that goes this direction, instead of just carrying on and completely missing us, gets bent. And so what happens is we see this shadow galaxy in a circle here and here. Because to our eyes, light always travels in a straight line, right? What?
And it does always travel.
Yeah, okay, all right, okay, yeah. Space-time is curved. Let's not get into it, Oliver, all right? The road that the truck is driving on is curved. The truck is not turning its steering wheel, okay? So, what we see is a galaxy on this side and a galaxy on this side. But really what it is the galaxy is back here. Behind the elliptical galaxy, because this has so much mass, it actually bends space-time in a way that the light follows the curve of the space-time. Are you happy with that explanation, Oliver? Is that physically correct enough for you? Okay. Thanks for keeping it straight, man. All right. Any questions on that? Gravitational lens, it's one of my very, very favorite things. It's such a cool concept. And it's fun to say. Gravitational lensing. So again, there's this elliptical galaxy right here. And what you're seeing is a spiral galaxy that is actually behind this galaxy. And all the light is being bent around. It's pretty crazy stuff. Okay? Here's a better diagram of it. You have this source, and it goes whoop, and it gets bent by the gravity. So it looks like the star is here to our eyes, or here to our eyes, when in reality it's actually here. Okay? This one's the best. Looks like a happy face. So we have two elliptical galaxies with a whole bunch of gravity that are bending the light from the galaxies behind them. Aliens. Okay? So that's galaxies for you. We have over 1 trillion galaxies in the known universe. Each one of those galaxies has an average of about 100 billion stars. Billions. 100 billion stars. Okay? Questions on any of that so far? That's a lot of stars. Yep. Sure is. Don't forget to like and subscribe. Goodbye.